Okay, we have a scenario where we're driving our car and we've run over a nail, which has presumably damaged our tire. And the problem says that as the air leaks out of your tire, and here's the key thing we're looking for, this phrase, it says the rate of change of air pressure, P, is directly proportional to that pressure. That's that key phrase you're looking for. That tells us that we can use the differential equation we've solved that has to do with growth and decay. Okay. So whenever you're working a problem and you see that phrase, you're in a good place because you can shortcut solving the differential equation. Of course, part A of this problem does ask us to write and solve the differential equation. But we've already solved it. So once we write what we've got going on, we should be able to jump right to a solution. So when I see the rate of change of air pressure, that to me screams dp dt. The rate of change, how fast is the pressure changing with respect to time? Is, of course, means equal to. It's directly proportional to the pressure, directly proportional to P. So just like we did last time, we're going to use that K times P, where here's our constant of proportionality. There needs to be some constant there because I don't know if that rate of change is always positive or negative. It could be either scenario. In this case, since P is the air pressure, as time goes on, when I pop my tire, the pressure is going to decrease. I bet K is negative. But now they want us to solve this differential equation, and the good news is that we know what the solution to this differential equation is. We saw previously that anytime we have the differential equation d whatever dt equals K times that whatever, that the solution would be like this. P equals P sub 0 times e to the kt. And I chose P here instead of y because the amount that we're interested in, that pressure, is P this time. So there's step one. Okay, part B of our problem then says this. At time 0, the air pressure of the tire is 45 psi, that's pounds per square inch. 5 minutes later, the air pressure is 38 psi, and they want to know what the air pressure will be at t equals 10 minutes. Well, when t is 0, P is 45, and you know, this value is P when t is 0. So I think what this information tells me is that P sub 0 rather, is 45. If I were to let t be 0, this whole term would be e to the 0th power, which is 1, and P would have to equal P sub 0. Now, 5 minutes later, the air pressure is at 38 psi. So that's telling me that when t is 5, P has to be 38. And I think I can use that information to find K. I think I can find K now. Because I know P0, and I know a time and a pressure. I could be able to use this equation and find K. So I'll plug in what I know, that I get 38 for my pressure when P0 is 45, e to the K times t, which is 5. And I believe I can solve that for K by dividing both sides by 45. You know, this is now e to the 5k, right? Because k times 5 is the same as 5k. If I were then to take the natural log of both sides, so ln of 38 over 45, would equal ln of e to the 5k. The ln of e to the 5k is just 5k. So K would have to be the ln of 38 divided by 45, all divided by 5. And I think I need my calculator. So we need ln of 38 divided by 45. And then we need to divide that by 5. And I get a value for K, and notice that it is negative, which made sense in this scenario, of negative, we'll go to about 3 places. We'll go negative 0.034. Negative 0.034. Alright. But now we still haven't really answered their question. They want to know, well, what's happening when t is 10 minutes? Well, I know K now. So I can find the pressure if I use time 10. So the pressure would be P0, that's 45. E to the, we've got a value for K now, 0.034, and they want to know about time 10 minutes. No big deal. Maybe over here. So we want 45 e to the negative 0.034 times 10. And I get about 32.030. And the units on the pressure, P, that's PSI. Okay. The car is safe to drive as long as the pressure is 20 psi or greater. The part C asks, for how long after the puncture will the car be safe to drive? So if I go back, I found my values for P0 and K. And I just copied them over here. P0 was 45, K was negative 0.033. And I'm still using that same expression, P equals P sub 0 e to the KT. So I think I simply could plug this 20 psi in here for the pressure. I know P0 and K, and I could find the time when the pressure would reach 20. So I get a pressure of 20. My initial pressure, P0 is 45, e to the K times T, and I can solve this for T. Kind of the way we did in the last step to find K. I could divide both sides by 45. And my next step here would be then to do ln of each side. And of course, on the right side, the ln of e to the whatever is just the whatever. So the right side would now just be negative 0.033t. And then to solve that for t, well, t would be the ln of 20 divided by 45 divided by a negative 0.033. So ln of 20 divided by 45 divided by negative 0.033 gives us about 24.573. And you know, previously t had been measured in minutes, so we'll use that for t now. So better get to a tire station on that thing. You got some problems to try now that are very similar to this, and that you need to write the differential equation. You can use the shortcut that we know previously to solve it, and then you need to apply it a little bit, apply that solution.